The heat wave gripping much of the world right now is already dying. But what is quietly building behind it, deep beneath the surface of the Pacific Ocean, is the reason climate scientists are watching their monitoring screens with a particular kind of focused unease that is different from ordinary seasonal concern. Some of the tracking maps used to visualize global temperature records are already running out of colors. The scales these systems were built on, designed by meteorologists who thought they were creating a chart capable of representing anything the planet could produce, are being pushed past their own limits. Stay with this for the next few minutes, because the story everyone is talking about right now, the current heat, is actually the smaller half of what is happening. The real story is what comes after the heat fades. And right now, in July 2026, multiple independent forecasting centers around the world are pointing toward the same conclusion about what that replacement looks like. It is not cooler. It is not a return to something comfortable and familiar. It is something that has pushed global temperature records into new territory every time it has appeared in the historical record. And according to the most current ocean data available today, it is forming right now beneath the surface of the Pacific in a pattern that forecasters describe as a rapid and accelerating transition. This is not a single alarming source running a worst-case scenario. This is the consistent conclusion being drawn independently by NOAA's Climate Prediction Center, by international forecasting bodies across Europe and Asia, and by every major seasonal modeling system currently tracking subsurface Pacific Ocean temperatures. They are all looking at the same data. They are all reaching the same conclusion. And that consensus is why this particular shift deserves more attention than the heat wave dominating today's headlines. To understand what is coming, you need to understand a cycle that quietly governs the entire planet's weather, whether most people have ever heard of it or not. It is called the El Niño-Southern Oscillation. Scientists shorten it to ENSO. It describes a natural recurring shift in ocean surface temperatures across a massive stretch of the tropical Pacific, from the coast of South America westward across thousands of miles of open ocean toward Asia. This cycle has two opposite phases, and the planet has been swinging between them for as long as ocean temperature records exist. La Niña is the cooler phase. During La Niña, sea surface temperatures across the central and eastern tropical Pacific run below their long-term average. El Niño is the warm phase, the precise opposite. During El Niño, those same stretches of ocean heat up well beyond normal. Neither phase is permanent. The cycle swings back and forth every few years, and every time it does, weather patterns shift across nearly every continent on Earth simultaneously, not as a vague, abstract influence, but through specific, documented mechanisms that meteorologists have tracked across decades of careful observation. The physical mechanism driving this swing comes down to wind and water, working together in a self-reinforcing feedback loop. Under neutral conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water westward toward Asia, and allowing cooler water to rise from depth near South America. During La Niña, those trade winds strengthen, intensifying the natural pattern and cooling the eastern Pacific further. During El Niño, the trade winds weaken, sometimes reversing direction entirely, which allows the warm water normally pinned near Asia to slosh back eastward across the entire Pacific basin. A much larger stretch of ocean surface is suddenly covered by unusually warm water. Oceans store heat far more efficiently than the atmosphere does. When that stored ocean heat is exposed to the surface during El Niño, it radiates upward into the atmosphere above it, effectively creating a new engine that drives pressure systems, jet streams, and storm patterns across thousands of miles in every direction. The tropical Pacific becomes a different kind of heat source than normal, and the entire planetary atmosphere reorganizes itself around that changed heat source. For the past 2 years, the planet has been sitting inside a weak La Niña pattern. And here is the detail that should stop you for a moment. Even during that supposedly cooler phase, the summer of 2025 and the opening months of 2026 produced record-breaking heat waves across Europe, dangerous and sustained heat domes across the United States, and extended heat alerts affecting enormous portions of the American population. Regions that historically expected La Niña to bring some relief from extreme heat received none. The baseline global temperature has climbed so high that even the cooler half of this natural ocean cycle is now capable of producing historic and dangerous heat events on a near-annual basis. That is the context for what comes next. And what comes next is this. La Niña is now collapsing. The cool phase is breaking down rapidly, and the data from both surface and subsurface ocean monitoring is pointing toward the formation of a new El Niño event that multiple forecasting centers now expect to strengthen into a strong, possibly super El Niño by the time it reaches its peak during the coming Northern Hemisphere winter. This matters enormously because of one well-documented pattern that has repeated itself across the historical record with enough consistency that climate scientists treat it as a reliable leading indicator. The hottest years ever measured on this planet did not happen during La Niña years. They happened during strong El Niño events, or in the year immediately following one, when the extra ocean heat released during El Niño was still working its way through the climate system, even as the ocean itself began cooling back toward neutral. Look at the record. The extremely strong El Niño of 2015 and 2016 pushed 2016 into the record books as the hottest year ever measured at that time, a record that stood for years. A strong El Niño developed through 2023, and that year broke the global temperature record outright. Then, 2024 broke it again, with the lingering atmospheric warmth from that same El Niño event continuing to drive temperatures higher, even as the ocean cycle itself had already begun its transition. That is, 2 consecutive record-breaking global temperature years, driven in significant part by a single El Niño event and its aftermath. This is not a pattern that appeared once or twice and faded. It has repeated itself across multiple El Niño cycles, spanning decades of direct measurement. Climate scientists now treat an incoming strong El Niño as a fairly reliable early warning that global temperature records are likely to fall within the following 12 to 18 months. The natural ocean cycle and the long-term warming trend from greenhouse gas accumulation stack on top of each other when El Niño peaks. And when they stack, the results tend to enter historically unprecedented territory. Now the maps. Because this is where the story becomes visually strange in a way that is difficult to set aside once you understand what you are looking at. Weather and climate agencies around the world use color-coded temperature maps to communicate forecasts and records to the public. The standard scale runs from cool blues representing below average temperatures through yellows and oranges to deep reds representing extreme and dangerous heat. For most of the history of modern meteorology, this scale was more than adequate. Red at the top represented the worst scenario imaginable. Temperatures so extreme they were considered genuinely exceptional events unlikely to repeat within a forecaster's career. That stopped being adequate. In 2013, Australia's Bureau of Meteorology had to redesign its own national forecasting charts, adding entirely new colors, deep purple and then vivid pink, to the top of the scale specifically because Australian temperatures were pushing past 50 degrees Celsius, a threshold the original color system was never built to display. This was not a symbolic gesture or an artistic choice. The existing chart literally could not visually represent temperatures that high. The scale had been calibrated on the historical record of Australian temperatures, and that historical record had become insufficient for representing what Australian summers were producing. That same scenario has repeated itself in forecasting systems around the world in the years since, just with different specific thresholds each time. During major heat waves across Europe in recent summers, meteorologists found that the bright red traditionally used to represent extreme danger was no longer adequate to visually separate a severe heat wave from a genuinely unprecedented one. When multiple regions across multiple countries simultaneously push into the top end of the existing scale, the scale loses its ability to communicate relative severity. Everything looks identically red, even when the temperatures are separated by margins that have enormous practical consequences for human health and infrastructure. Forecasting systems have been forced to introduce darker maroons, deep purples, and, in some visualization systems, shades approaching black to represent temperatures that fall so far outside historical norms that the original map design simply has no representation for them. When a chart designed specifically to communicate the worst possible scenario has to keep adding new worst possible scenario colors, that is not dramatic exaggeration for public effect. It is a practical sign that the range of what happens on this planet has shifted beyond the boundaries of what the instruments built to track it were designed to contain. There's a straightforward reason this keeps happening, rather than agencies simply building larger scales at the outset. Weather and climate mapping systems are built using historical data. The color range is calibrated against the most extreme temperatures ever recorded in a given region. At the time the map was created, for decades, that approach worked reliably because genuinely record-shattering temperatures were rare enough that existing scales needed adjustment only occasionally. What has changed is the frequency. Record-shattering temperatures are no longer exceptional enough to treat as design edge cases. They are appearing repeatedly, sometimes within the same season in the same region, forcing agencies to treat scale redesign as an ongoing technical maintenance requirement, rather than a rare historical event. Some meteorologists have begun describing their work as chasing a moving target, redesigning the chart only to find, within a year or two, that the new extreme colors are already being tested by the next record-breaking event. The tools built to track what the planet does keep falling behind the planet. Now here is why the incoming El Niño raises the stakes on this pattern specifically. During an El Niño event, the tropical Pacific releases an enormous quantity of stored ocean heat directly into the atmosphere above it, heat that had been accumulating beneath the surface during the preceding La Niña and neutral periods. This atmospheric heat injection pushes global average temperatures noticeably higher on top of whatever long-term warming trend is already operating from accumulated greenhouse gas concentrations. The two forces add together. The natural ocean cycle amplifies the long-term trend, and the combined result tends to produce the kind of temperature anomalies that make map designers reach for colors they had not previously needed. The current forecasting picture has an important characteristic that climate scientists specifically watch for when evaluating the reliability of long-range predictions. Multiple independent modeling systems, using different data inputs, different computing architectures, different research methodologies, and operated by different institutions in different countries, are all converging on the same basic outcome for this El Niño transition. Strong model agreement of this kind is treated by forecasters as a high confidence signal, qualitatively different from the output of any single model, which can occasionally produce outlier results based on its own particular assumptions. When institutions that have no coordination with each other, working from different starting data, all arrive at the same conclusion, that convergence is meaningful. And right now, the convergence in the forecasting community around a strong El Niño developing by the winter of 2026 into 2027 is among the clearest multi-model agreements climate scientists have flagged in recent years. The regional effects of this shift are specific and documented across previous El Niño cycles, even though the exact expression varies somewhat depending on the strength and timing of each individual event. Parts of the southern United States that often experience drier conditions during La Niña tend to see wetter patterns return as El Niño establishes itself. The Pacific Northwest and northern tier of states, which frequently see wetter, La Niña winters, often swing toward warmer and drier conditions under El Niño influence. Across the Pacific, El Niño years have historically been associated with reduced Atlantic hurricane activity, because the stronger upper-level winds El Niño produces tend to disrupt tropical storm formation in the Atlantic, even as they simultaneously raise drought and wildfire risk across Australia, Indonesia, and parts of southern Asia that depend heavily on rainfall El Niño tends to suppress. None of these regional tendencies play out identically in every event. El Niño does not override all other weather-driving factors simultaneously, but the broad directional shifts have been consistent enough across the historical record that seasonal forecasters build their regional outlooks around them every time a new event forms. There is a distinction worth making clearly here, because it separates the honest scientific picture from both extremes of how this kind of story sometimes gets presented. ENSO, cycles are natural. They have been swinging between El Niño and La Niña for as long as the ocean has existed in approximately its current configuration, long before industrial emissions became a factor in Earth's energy balance. Nobody credible is claiming that El Niño itself is a product of climate change. What climate scientists are pointing to is something more specific and more measurable. This entirely natural cycle now operates on top of a planet that is already roughly 1.25 degrees Celsius warmer on average than it was before industrialization began. That shifted baseline changes what the natural cycle produces even when the cycle itself behaves identically to how it always has. A useful mental model for this is a swing set installed on a floor that keeps slowly tilting upward over time. The swing moves back and forth exactly as it always has, following the same natural rhythm, reaching the same angle on each arc. But because the floor beneath it keeps rising, every arc of that swing reaches a higher absolute point than the arc before it, including the arcs at the low end of the swing's range. The mechanics of the swing are unchanged. The surface it operates on has shifted, and that shift is what keeps translating ordinary natural oscillations into record-breaking outcomes. This is also why the specific overlap of El Niño timing and long-term warming background draws particular scientific attention. The years when a strong El Niño and an already elevated baseline temperature have aligned are consistently the years that land at the very top of the global temperature record. Not because anything unprecedented happens to the physics of the climate system in those years, but because two well-understood forces happen to be pushing in the same direction at the same time. If current forecasts hold, and this event does strengthen into a strong or super El Niño, by the end of 2026, the following year carries a genuine statistical probability of setting new global temperature records. Not a certainty. Weather systems are complex and variable enough that guarantees are never available, but a real probability based on a pattern that has repeated itself across multiple previous El Niño cycles with enough consistency to treat it as a meaningful leading indicator rather than a coincidence. This does not mean every single day of the next 18 months will be unbearably hot everywhere simultaneously. Weather at the local scale remains messy, regional, and full of short-term variability that no single ocean temperature pattern can fully control. Some regions will experience conditions that feel like genuine relief from certain stresses, particularly areas that benefit from the specific rainfall patterns El Niño tends to bring. The planet does not have a single universal experience of any given climate pattern. But on the scale that matters for tracking where global temperature records land, meaning the yearly planetary average rather than any individual city's forecast or any single afternoon's reading, The transition underway in the Pacific right now is one of the more significant and clearly forecasted shifts the scientific community has flagged in years. The model agreement is strong. The historical pattern is consistent. The baseline on which this event is superimposing itself is higher than at any previous point in the instrumental record. The complete and honest picture, without exaggeration and without minimization, looks like this. The heat dominating headlines right now in July 2026 is genuinely likely to ease as the current weather pattern breaks down. Individual heat waves always end. That relief is real, and it is coming in the near term. But underneath that short-term relief, a much larger and slower-moving transition is already underway beneath the Pacific's surface, one that multiple respected forecasting centers now expect to deliver a strong El Niño event by winter, and one that the historical record consistently associates with global temperature records, falling in the months that follow. The maps that track these temperatures keep needing new colors for a reason that has nothing to do with dramatic presentation choices by the agencies building them. The old colors were calibrated for a version of this planet that no longer fully exists. Meteorologists are stuck playing catch-up with a climate system that keeps testing the upper edge of whatever scale they just finished redesigning. That is not a single dramatic event pushing these charts past their limits. It is a slow, steady, well-documented climb, one El Niño and one La Niña at a time, each cycle landing on a slightly higher baseline than the one before it, until the tools built to track it have to be rebuilt just to keep functioning. Whatever color eventually gets added to represent the next record, the story behind it will be the same one just described here. A natural ocean rhythm operating on top of a floor that keeps rising. The rhythm itself unchanged. The baseline beneath it, quietly and persistently, going nowhere but up. The Pacific has already made its decision about what comes next. The maps are about to find out whether they have the colors for it,